Here we're going to discuss what are called identities in trigonometry. Before we do that though, we need to get some examples of simplifying trigonometric expressions. So here I have 1 take away the square of cosine divided by the square of secant take away 1. Now we're asked to simplify, right? So now when you simplify, what that means is use a combination of other trigonometric identities and algebraic techniques to write this in a simpler way. So for example, when I look at that numerator, the first thing that jumps out at me is that I have 1 and the square of cosine. And right away that makes me think of the identity sine squared plus cosine squared is equal to 1. So I know this identity is always true. And if I subtract the square of cosine from both sides, right, take away the square of cosine, I get this. That sine squared is just 1 take away the square of cosine. So in other words, 1 take away the square of cosine is simply the square of sine. So I'm going to replace this with the square of sine. And likewise, that denominator, I see the square of secant and 1 again, and that makes me think of the identity 1 plus the square of tangent is equal to the square of secant. And so if I subtract 1 from both sides, I get tangent squared is equal to secant squared take away 1. So let's replace secant squared take away 1 with the square of tangent. So this becomes, we said the numerator was going to be the square of sine, and that denominator is going to be the square of tangent. And now we can simplify this further, and the reason is because, well, I see tangent, right? But I know that tangent, I know that's equal to sine divided by cosine, right? And I'm gonna expand out tangent so that I can cancel a sine here. So this becomes the square of sine. Okay, now the tangent and the square of tangent in the denominator, I'm going to write the square of sine divided by the square of cosine, right? That's tangent squared. And now this is sine squared divided by this fraction. And algebraically, I know that the sine squareds cancel, and this cosine squared in the denominator, this is in the denominator of the denominator, that comes all the way up into the numerator, and I just get the square of cosine. Okay, so this would be a simplified version of this expression. Clearly this is simpler than that. Now what we're going to do now is we're going to go on and establish what are called identities. And identities are basically equations that you're trying to verify that they're true by simplifying one side. Let's see how that works now. So we're asked in this problem to establish the identity, and you see that I have two expressions, right? This expression equal to that expression, right? This is not like the previous problem because I have an equality sign here. When you are trying to establish an identity, what you're trying to do is show that this is true. And the way you do that is by taking one side and simplifying it, and hopefully show that that simplified version is the other side. So when you see the instructions establish that the identity, you can really think of that as show true, that is, show the equation true by simplifying one side. Okay, that's basically what we're talking about here. You simply choose one side of the equation, simplify it, and after you're done simplifying it, you should end up with the other side of the equation. But it's important with identities that you only work with one side, okay? You're not allowed to work with both sides simultaneously. So what you do is you pick the more complicated side. So I'm going to look at these and say, well, they're both kind of complicated, but I'd say this one's a little more complicated than that one. So I'm going to take this side only and simplify it, okay? Just like I did in the previous example. And when I'm done with that simplification, hopefully I get that right-hand side. All right, let's see how this works. So we take 3 cosecant x, take away 3 sine x, and I simplify that. So what I'm going to do is I'm going to write this as, well, I'm going to write that cosecant as 3 divided by sine, then take away 3 times sine. And now what I'm going to do is I'm going to get a common denominator, right? This is a fraction over 1. So I'm going to multiply top and bottom of this by sine. So let's write that times sine for the numerator, and then times sine for the denominator. And so this one stays the same, so it's 3 over sine x, and then take away, but this becomes 3 sine squared x, right? Sine x times sine x, divided by 1 times sine. And now that they have the same denominator, I'm going to write this as 3, right? This numerator, take away that one. Take away 3 sine squared x. Okay, all divided by the common denominator, which is sine. And now I'm trying to simplify this still, right? So I see I have that sine squared, and when I see that, it makes me think of the 1 minus sine squared. So I'm going to factor a 3 out of both of these. Let's do that up here. So this becomes 3 times 1 take away sine squared, and then over sine. And then 1 minus sine squared, as I talked about in the previous example, that's the same as cosine squared. So it's 3 times cosine squared x divided by sine x. Okay, now you're thinking to yourself, where are we trying to go? We're trying to show that this can be simplified into that. Okay? Now I compare where I'm at right now, which is here, with where I'm trying to end up, which is there. And I see that I have a cotangent. So what I'm going to do is I'm going to break up this cosine squared into 3 cosine x, and then over sine x. So I just simply broke up that cosine squared, and so it becomes 3 cosine x, cotangent x. And the problem is finished. That's my answer. So the point of these is that you're trying to show that you start with one side and simplify and end up with the other side. Okay? And that's how it works. That's what it means to establish an identity. We're done with this problem. All right, let's try another one like that. And the little check mark for identities means, yep, we're good. All right, let's try another one. Okay, establish the identity. So remember how this goes. You look at the two sides and say, which one's more complicated? Well, clearly this one, okay? And then what you do is you take that side and simplify it and hopefully get the other side at the end of the day. So let's do that. Take the entire left-hand side, and don't forget there's this minus 3 on the left-hand side as well. So it's going to be 3 sine times tangent divided by 1 take away cosine, take away 3. Okay, I'm going to simplify that. So the first thing I notice is that I have a tangent here. Often when we're simplifying, we write the tangent as sine over cosine. Okay, so it's going to be 3 sine theta. Okay, and this tangent becomes sine over cosine. Right, and then I still have in that denominator 1 minus cosine theta. And don't forget, the little minus 3 is still coming along for the ride. Okay, so this becomes, let's write that numerator as 3 sine squared theta, multiplying the sines together. And I still have that over cosine theta, and that's all in the numerator, right? Divided by 1 minus cosine theta, and then still minus 3. So basically, I multiplied these together in the numerator. Now, algebraically, this is what we call a complex fraction, and that's because you have a fraction within a fraction. And we like to clear those, so I'm going to multiply top and bottom of this fraction by cosine theta. I'm trying to get rid of this cosine theta. I'm trying to get rid of the fraction within the fraction. So it's going to be cosine theta over 1 for this numerator, and then that means I have to multiply this by cosine theta as well, because cosine theta over cosine theta is 1. I don't want to change it, I just want to eliminate that denominator. All right, let's carry on up here. Okay, so the cosines cancel, that's the whole point, and I get, it's going to be 3 sine squared theta, that's in the numerator, divided by, and I still have this denominator, which is, let's write it as cosine theta times 1 minus cosine theta minus 3. Don't forget that little minus 3 right there. Okay, now what we're going to do is we're going to get a common denominator, because this is like minus 3 over 1. So I'm going to multiply top and bottom of this by cosine theta times 1 minus cosine theta. I'm going to get a common denominator. Let's go ahead and write that here. So cos theta, 1 minus cos theta, that's for the numerator, and same thing for the denominator. 1 minus cos theta, there's room right there. All right, so we're going to get 3 sine squared theta, okay, minus. Now, this is going to be minus 3 cosine theta. I have to distribute that negative 3 cosine theta, and then it becomes plus 3 cosine squared. Do you see that? All over the common denominator, which is cosine theta times 1 minus cosine theta. Let me just review that with you to make sure you saw it. Negative 3 cosine theta, this has to get distributed. First you multiply it by 1 and you get negative 3 cosine theta, and then you take that negative 3 cosine theta and you multiply it by the negative cosine theta to give positive 3 cosine squared theta. Okay, then once you've done that, because these have the same denominator, you can put them over that common denominator. And now, do you notice anything? Well, do you see how we have the sine squared and the cosine squared? Let's get these two together and then factor out that 3. So it's going to be 3 times sine squared theta plus cosine squared theta. And I still have this minus 3 cosine theta in the numerator. Okay, all over the denominator, which hasn't changed. Cosine theta times 1 minus cosine theta. Now, why did we do that? Because sine squared theta plus cosine squared theta, using an identity, this is equal to 1. So it's basically 3 times 1, or just 3. And then you still have minus 3 cosine theta divided by cosine theta, 1 minus cosine theta. And now what I'm going to do, I'm going to factor 3 out of both of these. So it's 3 times 1 minus cosine theta over that over that denominator, cosine theta times 1 minus cosine theta. And now we cancel the 1 minus cosine thetas. I'm going to cancel all of this with all of that. So boom, boom. And I can only do it because it's multiplication, right? And so then I have 3 divided by cosine theta. And then finally, 1 over cosine theta is secant theta. So I get 3 secant theta. And so all this simplification led me to 3 secant theta, which is exactly what I was showing it could be simplified to. And so I'm finished. All right, so I just established this identity. All right, so we'll have some more practice establishing identities, but remember, you're just trying to simplify one side until you get the other side. Okay, until next time.